Next we look at the applications of cross product. We have already seen that cross product between two vectors A cross B by definition is A B sin theta into n cap, where n cap is a unit vector which gives us the direction of the vector A cross B, and it is given by the right hand thumb rule. It is a vector which points perpendicular to the plane that contains the two vectors A and B. It is always perpendicular to both A and B, right. So, we have also seen that the cross product between vectors can be written in a matrix form, which is written as I cap, j cap, k cap in the first row, Ax, Ay, Az in the second row, and Bx, By and Bz in the third row. We use this form when the two vectors are given in their rectangular component form. Now, where do we use cross product? The first application of cross product is in checking whether two vectors are parallel to each other or not, because we know that if vector A is parallel to vector B, the angle between them theta will be 0 degrees, and that means that the cross product between the vectors will be 0. So, if somehow we get the cross product between two vectors as 0, we can say that the two vectors are parallel to each other. Second application is in finding out the area of a triangle or a parallelogram which are formed by the vectors A and B. To find area of a triangle or a parallelogram. How do we do this? Let us see. Let us say we have two vectors A and B drawn such that their tails are coinciding. If this is how we draw them, and we also know the angle between them. As we know the two vectors A and B, understand that the triangle formed by these two vectors is then a fixed triangle. It looks like this, right. The third side will be fixed once the first two sides of a triangle and the angle between them is fixed, the third side is automatically fixed. So, in order to define a triangle, we just need two vectors, right. Now, how do we find out the area of such a triangle? By definition, the area of a triangle is given by half into the base of the triangle into its height, isn't it? Now, if we look at this figure here, the base of this triangle is nothing but the length of vector A, the magnitude of vector A. So, we can write half into the base length is magnitude of vector A into the height of this triangle. If you try to find out the height by dropping a perpendicular from the tip, the upper vertex, and trying to find out this length, using trigonometry, it can be proved that this length comes out to be B sin theta. You can try checking this. So, the height then becomes B sin theta, and if you look at this expression carefully, you are getting half into AB sin theta. What is AB sin theta? AB sin theta is nothing but the magnitude of the cross product of two vectors, mod of A cross B. So, if two vectors A and B are forming a triangle, then we can easily find out the area of the triangle by just finding out the cross product of the two vectors and just finding out the half of it, right. On the same lines now, if we look for a parallelogram formed by similar two vectors A and B, let us say vector A and vector B. Once again, understand that if we define two vectors with the angle between them, that means we have defined the parallelogram formed by those two vectors. All we need to get the full parallelogram is just draw parallel lines to the tips of the vectors that meet on the other side, to form the parallelogram. Now, how to get the area of the parallelogram? By definition, area of a parallelogram is given by its base length into its height. Base into height gives us the area. Now, the base here is nothing but the magnitude of vector A, and the height of this parallelogram, as we have done above, it is the same, it is B sin theta here. So, A into B sin theta gives you the area of the parallelogram, which in our case is nothing but once again magnitude of A cross B, magnitude of the cross product of the two vectors, right. So, all we need to do to find out the area of a parallelogram formed by two vectors is just find out the cross product of the two and find out its area, right. So, these are some basic applications of cross product between two vectors.